For part 3, we'll explore Venn diagrams, complements, unions, and intersections. A Venn diagram is like a box, like picture a shoebox, and inside the shoebox you're going to have circles, and these circles represent events. So in my Venn diagram, and just a visualization of the sample space, so the box contains every element in the sample space, and the circle contains everything in the event. It should be noted that you can have up to 3 circles in a Venn diagram. Beyond 3 circles, you can't include every possible option, so you have to go to other shapes. So Venn diagrams usually have 1, 2, or 3 circles in them, 3 events, up to 3 events. So there's a few different methods for diagramming something in a Venn diagram. So let's just use an example to show this. Suppose we have an experiment where we roll a 6-sided die. Let E equal all the even numbers and M be all the numbers that are more than 2. Let's illustrate this with a Venn diagram. One way is the listing method. So let's see, we can roll a 1, and if we roll a 1, it wouldn't be even or more than 3, so it would be outside somewhere loose in the box. If we roll a 2, well, that's an even number, but it's not more than 2, so it would go over here. If we roll a 3, it's not even, but it is more than 2, so it would go over there. And we can just finish rolling these. Okay, so we have a 2 is even, but it's not more than 2. We have 4 and 6, that is both even and more than 2. And 3 and 5, that's more than 2, but not even. And then 1 is none of those. And that's just one way to show something on a Venn diagram. Another way is just counting the number of elements in each part. So we have 1 element that's in the even-only group, 2 elements that are in both, 2 elements that are in the more than 2 group, but not even, and then 1 element outside, loose in the box. And again, you can put these numbers really anywhere in those regions. A third method is to do probabilities instead. So we're just going to take each of these numbers and divide it by 6, since there's 6 possible outcomes. And we'll get 1 6 here, 1 6 here, 2 6, or 1/3 in the middle, and then 1/3 in the more than 2 group, but not even. Let's explore something called complementary events. For complementary events, we're looking at the region, the loose region in the box, not what's in our event. When we're looking at a word problem, a complementary event will be indicated by the word not in front of it. So we might say, instead of E, we'd say not E. So one way to write this is the complement of E would be EC or E prime. Either method is pretty common. This EC method is a little bit more common today. But this is just basically saying not E, not event E. So for our example, suppose we roll a 6-sided die and our event is M rolling more than a 2. Then not M, not getting more than 2, would be rolling a number less than or equal to 2, which would include 1 and 2. So MC would be the numbers, or the complement of M would be the numbers 1 and 2. Intersection in a word problem is really just the overlap between 2 regions. So the intersection of sets A and B would be the overlap between A and B, like the intersection of 2 roads is the overlap of 2 roads. For an intersection, we use the symbol. It looks like an upside down U, an upside down capital U, sort of, but it is its own mathematical symbol. And it's just another way to write A and B. And we're looking for, again, the overlap between A and B. So going back to our example, I should have probably labeled this E intersection B instead. E intersection M instead. But looking at this example here, we're looking for the overlap. So it would be just this region. That would be the overlap of E intersection M. So let's consider what happens if we want everything. In a word problem, we would use the word or to indicate that. So we'd want something like A or B. The symbol we use for this, well, is the union symbol, and it looks like a capital U. Again, it's its own special symbol. It's not really a capital U, but it looks a lot like it. So again, I probably should have wrote E union M here, but either way, it's going to be everything shaded. Everything in the circle shaded, because that would be E union M. Okay, so let's try to explore this. Suppose we roll a 6-sided die. Let E rolling an even number and M rolling a number more than 2. Let's find the following. Let's find E intersection M, E union M, E complement, and the probability also of getting an even and more than 2. So let's see, E intersection M, that would be the two numbers in the middle. So that would be 4 and 6. E union M would be all the numbers in the circles. So that would be every number except for 1. Okay, now let's try E complement. So we have 2, 4, and 6 that are our even numbers, so the complement would be the odd numbers. 1, 3, and 5, everything outside of the E circle. Okay, now let's try to do the probability of getting an even and more than 2. Well, as we showed, there were 2 numbers in the intersection out of 6 total numbers, so 2 out of 6, which is just 1/3.